Yeah, is this better? Okay, perfect. Okay, so to start this off, I'm actually going to flip this around and ask you guys a question. So I just want you to raise your hand if you think dirt and soil are the same thing. Okay, well, I thought just like you, my junior year of high school, I did not know that there was a difference between dirt and soil. So on my way to my ag class, my friend and I are walking and we come up to our ag teachers and we ask them this question. And they tell us, you're going to pretty much have to figure it out for yourself. And I want you to come back and tell us later in the day. And so that particular day, we pondered this question, and Spanish 3 quickly became soils class. So as we sat there thinking about this question and really just learning more and more into it, we began to Google a little bit more about soil and if it was dirt and how it really all played a factor. So we actually found out that in Illinois alone, there are more than 600 different kinds of soil, and that soil and dirt are not the same thing. So this sparked more and more questions about, do things grow differently in different kinds of dirt, or how that all plays a factor. But in order to understand how these, if things grew differently, we first had to understand a little bit more about the soil profile. So to start off, I'm going to relate this to these little decorative balls here. So soil is made up of different particles: sand, silt, and clay. So of the different three, sand is definitely the smallest particle. Then in the middle is silt, and then the biggest is clay. So this just has to do with how compact the soil is and the ultimate, the different soil makeup. So after learning a little bit about this, we decided to conduct a research experiment for our FFA project off of this, and basically just to see how different epigeel and hypogeel seeds would grow in different kinds of soil. So we collected 6 different soil types all across the state of Illinois, all with different amounts of sand, silt, and clay. And we wanted to test how the different seeds and how the different germination grew. So I drew a little bit picture here because I don't know if everyone is quite as much of a plant freak as I am, but so I'm just going to show you. So the top one here is epigeel, which is like your standard soybeans. So that just means that the cotyledon actually comes and has to burst through the soil in order to germinate into a plant. I don't know if you can see that. And then here on the bottom is the corn, and you can see that the cotyledon just has to remain under the soil and that it doesn't have to go through as much pressure as to push through the corn. So obviously, well, I guess maybe not so obvious, all these different factors of the different particle size and how much they weigh and how they compact all plays a factor in how different how the different crops can burst through the soil and ultimately grow. So of course, not just soil is the only factor that can play into germination. The weather plays a factor, the moisture, the heat, ultimately the compaction of the soil. This all plays a different factor in germination. So even though we did conduct this experiment, there were still obviously other factors that could have played into effect. But ultimately, when we did conduct this experiment and using the different kinds of sand, silt, and clay, or the different amounts of sand, silt, and clay, we got to learn that epigeel, so the bean seeds, the ones that have to push all the way through, do better in a clay or silty soil where the water can stay compact and that it actually has to like all the way push through. Where the hypogeel, or like the corn seeds, they where the root actually has to push through in the stalk, it does better with a silty or a sandy clay, so that is a lot more compact and that is a lot more compact because you have a lot of these as compared to just like one of these. So ultimately, this definitely sparked an interest in my crop science little thing that I went on for a while. My best friend and I actually got to go and we researched this project for 2 years throughout high school, and we conducted 2 different trials on it. The first one was just with soils in the United States, or in the state of Illinois, and then the second one we actually took to a national level and collected soil from all around the nation, which was actually really cool because at least I always thought, dirt is dirt. Like, you can't really tell a difference. But it's just so incredible of how the different makeups really affect the different plant growths, and that's why things grow differently all across the United States. So ultimately, dirt and soil are not the same thing, and that was kind of how I came to the realization of it, and just how different soils affect seedling emergence in crops. Thank you.